Chapter 25.4 The Definite Integral. This is in your textbook on page 757. Oops, 7. Let me change that to there. I'm going to work some of the book problems out for you to get an idea of how to do the definite integral. Now remember, we talked about the indefinite integral before this. The indefinite integral always had the plus c because we didn't know which problem we were referring to, or which original problem function we were referring to. In this instance, however, with the definite integral, we're given 2 points to evaluate or integrate at 2 given points. So we end up with an answer that does not include the plus c. So I'm going to start with number 3 in your text. Number 3 says, or lists 0 to 1, which means integrate this function from 0 to 1, and the function is 4x dx. To integrate or take the antiderivative of a function, we use the power rule that states take the power of the given variable and add 1 to it, and then divide by that new power. So we have 4x to the 1 plus 1 equals 2, so that would be 4x to the second, and divide by 2. And we're supposed to evaluate that between 0 and 1. Well, this simplifies to 2x to the second, and we're to evaluate that from 0 to 1, which is take your higher value first, substitute the 1 in, 2 times 1 squared, and then subtract the lower value substituted in, 2 times 0 squared, which equals 2 minus 0, which is 2. So when we integrate this function 4x dx between the points 0 and 1, we get an answer of 2. Let's try 5. So far, pretty simple. Integrate, that's the integrand symbol, 1 to 4, from 1 to 4, x to the 3 halves dx. Okay, now we have some fractional numbers here. So we have x to the 3 halves, and we have to add to it 1. We want to match this bottom number, so we're going to add to it 2 halves, which would give us 3 plus 2 would be 5 halves. So now I have to divide by 5 halves, and I have to evaluate this mess from 1 to 4. Well, if I multiplied this by 2/5, that would eliminate this on the bottom, but then I have to multiply the top by 2/5. So I end up with 2/5 x to the 5 halves evaluated between 1 and 4. We start by substituting the 4 in for the x. We would have 2/5 times 4 to the 5 halves minus, now let's substitute 1 in there, 2/5 times 1 to the 5 halves. Oh, great. These are great problems, huh? And 4 to the 5 halves you can put into your calculator, okay? This is going to be 2/5 times, that will give you 32, okay? Remember how you do this. The shortcut way to do it without a calculator, the square root of 4 is 2. 2 to the 5th power is 32. Minus 2/5 times 1 to the 5 halves power is just 1. So we have here 2/5 times 32, which will give us 64/5 minus 2/5 fifths, which gives us 62 fifths for our answer. And that is problem 5. Go on to problem number 7. Evaluate or integrate between 3 and 6 the function 1 over the square root of x minus 7 dx. So we're doing this whole thing. And what we want to do is just rewrite this first of all. From 3 to 6, we're going to integrate. 1 over x is the same as x to the negative 1/2 because it's in the denominator and it's to the 1/2. So to move it to the top, we would have to make it a negative 1/2 minus 7 dx. Okay, so that would give us, oh, sorry, let's erase that. Okay, now we're going to have x to the minus 1/2, add 1. Same bottom number, so add 2 halves, which equals 1/2 plus 2 halves is 1/2. But then we have to divide by the 1/2. Minus 7 becomes 7x. And we have to evaluate this mess between 3 and 6. So multiply this by 2 over 1 and multiply the numerator by 2 over 1. And we're left with 2x to the 1/2 minus 7x evaluated between 3 and 6. So let's start with 6. Substitute your 6 in wherever there's an x in both of these. That would give us 2. Remember, 1/2 is the square root of 6, because 1/2 is square root, minus 7 times 6 minus, let's substitute the 3 in wherever there's an x, 2 square root of 3 minus 7 times 3, which gives us 2 square root of 6 minus 42. Make sure you distribute your negative. Minus 2 square root of 3. Now a negative times a negative is a positive, plus 21. That then gives us 2 square root of 6 minus 2 square root of 3 minus 21. And that is your answer for number 7. Okay. Hopefully you're getting the idea of how to do each of these problems. It won't help, you viewing it won't help unless you do them yourselves. I would suggest you go through this video again, write the problem on a sheet of paper and try to do it yourself, and then rewatch what I do to make sure you have it correctly. Because we only learn math by doing math, not by just looking at math. Okay, problem number 9. Problem number 9 is, I don't think I like problem number 9. How about we go to problem number 11? I like that one much better. So let's skip 9. Okay, I'm going to change my color to red. Problem 11 states the following. Integrate from negative 2 to 2. The following: t minus 2 times t plus 2 dt. Alrighty, we can do that. First thing I'm going to do is FOIL this before I take the antiderivative. So we have integration, take the antiderivative between negative 2 and 2 of, let's FOIL. First would be t squared. Outer would be plus 2t, inner would be minus 2t, and last times last would be minus 4 dt, which gives us t squared minus 4 dt. Now that we've simplified that, let's do the antiderivative. So we would have, add 1 to this, so we would have t to the third divided by 3 minus this would become 4t, because remember, if you take the derivative of 4t, you get negative 4. And we are to evaluate this mess from negative 2 to 2. So we would have, let's start with 2 in the first brackets. 2 to the third over 3 minus 4 times 2 minus negative 2 to the third over 3 minus 4 times negative 2, which equals 2 to the third is 2 times 2 times 2 equals 8. So we have 8 thirds minus 8 minus negative 2 times negative 2 times negative 2 equals negative 8. Negative 8 thirds plus 16. Sorry, I guess I can't multiply. Plus 8. And what will we get here? Remember to distribute your negative to both of these. So this would be rewritten as 8 thirds minus 8 plus 8 thirds minus 8, which gives us 16 thirds minus 16. And I'm checking my work to make sure I did not make an error here. Let's double check this here. 2 thirds would be 8 thirds minus 8. And this would be and I am fine. And we could simplify this even farther if we wanted to. We would have 16 thirds minus 16 threes are what? 18, 48. That was just changing 16 to have the same bottom number as this one, which would be 3 times 16 is 48 thirds. So 48 minus 16 gives you your 2 negative 32 over 3. And hopefully you followed that in spite of my moving a little slow. Okay, I'm going to stop this video and I'll continue in the next one to make sure we're understanding how to integrate the definite integral.